Hello, and welcome to the Ohio DOT training for its Multimodal Design Guide, or the MDG. This video is the sixth module of a 13-part training series that will span the entirety of the guide. In this video, we will focus on the first half of Chapter 6, On-Road Bicycle Facilities. Chapter 6 covers bicycle facility design, including intersection design. In Part 1, we will cover general bikeway design for each facility. In Part 2, we will look at intersection design and crossing treatment selection for all facility types described on this slide. This chapter begins with an overview of the different types of bicycle route networks, which include local and regional routes established by cities and local agencies, state bike routes established by Ohio DOT, and U.S. bike routes established by the American Association of State Highway and Transportation Officials, or AASHTO. Any bicycle network should include route identification and wayfinding signs to help bicyclists navigate each bike route. In addition to standard bicycle facility pavement markings and signing, bicycle route signage should be used to help provide a visual identity to the bike network and differentiate those streets and paths from others that are not a part of the defined bicycle network. The Multimodal Design Guide describes signage options that should be used in concert with bicycle guide sign information in the OMUTCD Section 9B. Section 6.3 provides design guidance for all on-road bikeways. Although this section refers to these as bikeways, designers should understand that these facilities are also used by people on scooters, skateboards, and other micromobility devices, all of which should be considered in the planning and design process. At a high level, shared lanes and bicycle boulevards are similar in that the roadway is marked and signed to reinforce bicyclists' right to the road. However, all shared lanes are not bicycle boulevards. We will discuss the differences in more detail today. A pavement shoulder is sometimes provided to accommodate bicyclists, particularly in rural areas. And in our bicycle lane group, buffered bicycle lanes provide additional horizontal separation through pavement markings between the bicycle lane and the general purpose lanes, parking lane, or both. And a separated bicycle lane provides both the horizontal separation that a buffered bike lane provides and also provides a vertical element, such as a curb, parked car, or flex post within that buffer space. We will walk through each of these in the next few slides. Beginning with shared lanes. Shared lanes are the most common bicycle accommodation since bicyclists may operate on all roadways except where prohibited by the Ohio Revised Code 4511. Shared lanes may be identified with signage and marking or be left unmarked. Shared lanes are not recommended for roadways with speeds over 35 miles per hour. This section of the guide describes bicycle-friendly roadway design, including pavement, drainage grates, utility locations, bridge expansion joints, and more, signal detection to respond to the presence of bicyclists, crossing treatments that may be needed for uncontrolled crossing locations to facilitate bicycle movements, preferred signage and placement, marking design, including lateral placement, spacing along a roadway, and options at intersections to improve navigation, and most importantly, it discusses appropriate lane widths. Bicycle boulevards are designed very deliberately to manage motorized traffic volumes and speeds, prioritize bicyclist right-of-way at local street crossings, and provide safe and convenient crossings at major streets. The guide provides specific targets for motor vehicle speeds and volumes and how to reach those targets through traffic calming elements. The guide also describes appropriate signing, marking, and crossing treatments that are key for successful bicycle boulevard implementation. In 6.3.3, paved shoulders are discussed. Paved shoulders have been shown to provide many safety benefits for all users, but are particularly important for improving comfort and safety of bicyclists on roadways that meet any or all of the conditions shown here. Traffic volumes that exceed 3,000 vehicles per day, motor vehicle speeds greater than or equal to 50 miles per hour, inadequate sight distances for typical operating speeds or grades in excess of 5%, and high percentages of heavy vehicles. Shoulder width designed to accommodate bicyclists should be based on the roadway characteristics as seen in this chart. On two-way roads, it is preferable to provide paved shoulders on both sides of the road. However, in constrained conditions, the guide provides information on how to use the available space best. In this section of the guide, we discuss shoulder surface quality, rumble stripes and rumble strips, and also summarize bicyclist right-of-way at intersections based on the Ohio Revised Code. In part 2 of this training, we'll look at some of these treatments available to clearly indicate the right-of-way at intersections where bicyclists are expected to be traveling along the shoulder. Bicycle lanes, or bike lanes, are one-way bikeways designed for preferential use by bicyclists that typically carry bicycle traffic in the same direction as adjacent motor vehicle traffic and are distinguished from traffic lanes by striping, signing, and pavement markings. The widths prescribed in Table 6-3 accommodate a person's operating space, occasional passing, and shy distances to vertical elements as discussed in Chapter 3. The width of a bicycle lane does not include the gutter adjacent to the curb, and where a bicycle lane is adjacent to a gutter, the width of the bicycle lane should be measured from the edge of the gutter to the center of the bike lane line. The guide provides a discussion on how to use this table and when wider than the minimum widths should be considered. Every effort should be made to at least provide the minimum values. Chapter 7 discusses strategies to rebalance roadways in order to help achieve these values. The use of minimum values and other values are discussed in Chapter 1 and here in Chapter 6. You will see constrained values listed throughout the guide, and these guiding principles for when they are permissible hold true for all cases. When provided, bike lanes should be provided on both sides of two-way streets. A bike lane provided only on one side may invite wrong-way use. However, there are instances where providing a bicycle lane on one side may be acceptable. For one-way streets, the bicycle lane should normally be on the right-hand side of the roadway, but there may be scenarios, such as a frequent transit route, where it is appropriate to provide the bicycle lane on the left-hand side. The guide covers the variety of conditions a designer should consider and provide recommendations based on the context. Where on-street parking is permitted along a bike lane, the bike lane should be located between the parking lane and the travel lane. There are two types of on-street parking: parallel and angled parking. When parallel parking lanes are narrow, say 7 feet, and turnover is high, it is preferable to provide a separated bike lane to eliminate conflicts with vehicles, including vehicles crossing to park and doors opening into the bicycle lane. When a separated bicycle lane is not feasible or an interim solution is needed, a buffered bike lane should be provided, which can position bicyclists outside of the door zone. The guide provides steps a designer should take in order to rebalance the roadway to provide the preferred facility type and what to do after all options have been exhausted. Bike lanes should not be placed adjacent to head-in angled parking. Since drivers backing out of parking spaces have poor visibility of bicyclists in the bike lane. The use of back-end angled parking can help mitigate these conflicts normally associated with bicycle lanes adjacent to head-end angled parking. The guide exhibit shown on this slide includes typical design angle, width, and depth of back-end angled parking. Buffered bicycle lanes or buffered bike lanes are one-way bikeways designated for preferential use by bicyclists that are striped with a buffer space separating the bike lane from the general purpose lanes and or on-street parking lanes to increase the comfort of bicyclists. The width of the bike lane should generally follow the guidance for bicycle lanes. While the buffer is not a part of the bike lane width, it should be anticipated to be used by bicyclists to pass other bicyclists or to merge into the adjacent travel lane, and as such, the buffer surface should be traversable. The striped buffer of a buffered bike lane may include chevrons, diagonal lines, or wide pavement markings, depending on the conditions and widths available, as shown in this graphic. The guide discusses buffer widths and cross-hatching or chevron spacing as well. A conventional bicycle lane can be raised above the street grade to create a new bikeway type that provides more separation from vehicles when a separated bike lane, which we will review next, with horizontal separation is not feasible. Raised bike lanes can be raised to an intermediate level, which is between the street level and sidewalk level, or it can be located at the sidewalk height. In general, a separated bike lane is preferable to a raised bike lane to prevent motor vehicle encroachment and to reduce the potential for a bicyclist to crash while transitioning from the raised bike lane to the roadway at intersections. Raised bike lanes should not be installed adjacent to on-street parking due to the greater risk of dooring. Separated bike lanes are exclusive bikeways that are physically separated from the general purpose lanes. While buffered bike lanes provide a horizontal separation from motor vehicle traffic, separated bike lanes also provide vertical separation, such as flexible delineators or a curbed median. Separated bike lanes may be located at street elevation, sidewalk elevation, or at an intermediate elevation in between the sidewalk and the street. When building at sidewalk level, care must be taken to ensure that they are distinct from the sidewalk to discourage pedestrian encroachment and also to provide a detectable edge to meet accessibility requirements. Separated bicycle lanes are comprised of 3 distinct zones. The bicycle lane is the space in which the bicyclist operates. It is located between the street buffer and the sidewalk buffer. The guide provides recommended widths for one-way or two-way separated bike lanes based on bicycle volume, curbing type, and other contextual considerations. The street buffer physically separates the bicycle lane from a vehicle lane or on-street parking, both vertically and horizontally. Street buffer width is a central element in separated bike lanes and side path design and can be both continuous or intermittent, and the guide discusses widths based on the buffer type. A sidewalk buffer separates the bike lane and the sidewalk zone. When a separated bike lane is raised to sidewalk level, sidewalk buffers need to include a detectable edge so that pedestrians with vision disabilities can distinguish between the bike lane and the sidewalk. The design of sidewalk buffers should follow the recommendations in Chapter 4 of the Multimodal Design Guide. Some curb types can increase the risk of bicycle crashes if struck by a wheel or a pedal. Curb angle and height influence functional width of the bikeway, crash risk to the bicyclist, ability to exit the bikeway to access things like bicycle parking or adjacent properties, pedestrian detectability, and the risk of vehicle encroachment into the bikeway. 2 new curb types are available for separated bicycle lanes that can reduce the risk of a pedal strike. Curb type 10A is a sloping curb and is preferred along street level separated bike lanes. Curb type 10B is a mountable curb preferred along intermediate level separated bike lanes. These are also traversable by bicyclists. Both of these curb types can be found in Ohio's standard construction drawings for curbs. A bikeway between two vertical curbs needs to be wider than a bikeway between sloping or mountable curbs. Something to think about if space is an issue for your project. Where separated bike lanes are to be installed, designers must determine if it would be more appropriate to place a one-way separated bike lane on each side of the street, or to place a two-way separated bike lane or side path on one or both sides of the street. Selecting the appropriate configuration requires an assessment of many factors, including safety, overall connectivity, ease of access, public feedback, available right-of-way, curbside lane users, intersection operations, egress and ingress into the bikeway, maintenance, and feasibility. The analysis should also consider benefits and trade-offs of people bicycling, walking, taking transit, and driving. The primary objectives for determining the appropriate configuration are to provide a clear and intuitive transition to existing or planned links of the bicycle network, minimize conflicts between users, bicyclists, pedestrians, and motorists, and to provide convenient access to destinations. The guide provides two tables shown here and discussion for a designer to weigh the pros and cons of each option for their particular project to determine the appropriate configuration based on these objectives. Separated bicycle lanes push parking away from the curb, and where accessible parking or loading zones are present, the bikeway will need to be adjusted to accommodate these uses or activities and alert bicyclists to potential crossings. Accessible parking and loading spaces require additional space adjacent to the parking stalls for vans with ramps to allow passenger boarding and alighting, and to ensure an accessible route is provided to and from the sidewalk. Where accessible parking is needed on a street with separated bike lanes, it may be provided close to an intersection or at mid-block. The guide provides design guidance for these instances, including how the separated bike lane should be adjusted to accommodate accessible parking and loading zones. This is a good example of where constrained values may be appropriate, as they are only used for a short distance, and it is a design flexibility needed to accommodate other modes and access to properties. Finally, transitions between separated bike lanes and other bikeway types is essential for all projects that include a separated bike lane. The actual transition design can vary greatly from location to location depending on many of the contextual factors discussed throughout the guide. The selected transition design should clearly communicate how bicyclists should enter and exit the separated bike lane in order to minimize conflicts with other users. For transitions, it is generally more comfortable for bicyclists to transition after an intersection, as there are a lot of decision points for users when they are approaching the intersection. Where a bicycle lane transitions to a shared lane, it is also important to provide a space for bikes to wait before merging into the general travel lane. The guide provides 6 example transitions to help designers understand options available. Each treatment option shown in the graphic should be considered based on the intersection or transition location characteristics. Another design treatment that can be used for all bikeway types are bicycle ramps. Bike ramps are used to improve bicyclist safety or comfort, to shift the elevation of a bikeway to a different elevation, for example, street level to sidewalk level, or to change the bicycle facility type, for example, a conventional bike lane to a side path. It is common to use bike ramps when approaching roundabouts, at interchange ramp crossings, or at high conflict zones, such as weaving areas or high turning volume intersections. In these situations, the bike ramp serves the purpose of allowing bicyclists to avoid sharing travel lanes with motorists. In some instances, it may be appropriate to provide a bike ramp that would be used by most bicyclists, but to also provide an on-street option for the highly confident and somewhat confident bicyclist to allow them to ride in the shared lane environment. This section covers design parameters for bicycle ramps as summarized on this slide. Where to use a bicycle ramp is discussed as appropriate in the transitions to other bikeways and intersection design sections, including Chapter 9, Accommodating Pedestrians and Bicyclists at Complex Intersections and Interchanges. We will discuss their application some in training modules covering those topics and in other sections of the Multimodal Design Guide. In this video, we've highlighted the majority of the on-road bicycle facility design section of Chapter 6. Listed on this slide are other topics that can be found in 6.3 that were not reviewed in this video. As a reminder, we'll be covering intersection and bicycle crossings in Part 2 of this chapter's training. Finally, though we will not review these during our trainings, designers should be aware that there are sections with informations for overcrossings and underpasses and work zone bicycle accommodations. Thank you for watching this video covering Part 1 of Chapter 6 of the Multimodal Design Guide. For other chapters, please see the additional videos in this series.